Okay, class, I want to talk a little bit about synthetic division. This week we've done some long division. And long division is an important skill to have, and there are definitely times that you have to do long division. However, synthetic division is a shortcut to that, and it's a much quicker way to do it, and it can be used most of the time. So I'm going to use one of the examples that we had on our discussion board, and I want to show you how to do it using synthetic division. So our problem is x cubed plus 2x squared minus 5x minus 6. And we are going to divide that polynomial by x plus 3. Now we have done this with long division, and we know that the solution to this is x squared minus x minus 2. And since we did not have a remainder, we had a remainder of 0, we know that x plus 3 is a factor of this polynomial, and we also know that if I were to multiply x squared minus x minus 2 times x plus 3, then we would get our original polynomial, which is x to the third plus 2x squared minus 5x minus 6. Now the reason that synthetic division is important is because if you try to factor x to the third plus 2x squared minus 5x minus 6, you will notice that we cannot factor this by grouping. We could take out an x squared for our first two terms, but when I get to starting to take out something common in the second terms, the only thing that I get is a -1, and then I'm left with 5x minus 6. And as you remember, when we are factoring using the grouping method, these two binomials have to match. And so this particular polynomial, x to the third plus 2x squared minus 5x minus 6, cannot be factored by grouping. So we need another system to help us factor that. And synthetic division provides that. And it's a much quicker way to divide than using long division. So I want to talk a little bit about how to do that. So the first thing that we do is we are looking at x plus 3. X plus 3 is a factor, okay? X plus 3. The associated solution with this factor is -3. That is the associated solution. In synthetic division, we focus on the solution, not the factor. So if you are given the factor, you have to turn that factor into a solution. And if the factor is x plus 3, the solution is -3. And we get that because x plus 3 equals 0 is x equals -3. That's how we get that. So here we go. That's our first step. We take our factor and then we get our solution. The next thing that we do is we are going to focus on the coefficients of our polynomial. So if I've got x to the third, the coefficient in front of that is 1. This 2 is in front of my x squared, -5, and the negatives are incredibly important, so be sure you pull those, and -6. So I am going to write down on my synthetic division problem, I am writing down my coefficients. So I have 1, 2, -5, and -6. And this is the synthetic division process. The very first thing that I'm going to do is I am going to bring down my first coefficient. So I'm bringing down the 1. The next thing that I'm going to do is I am going to multiply this 1 times my -3. So I'm going to have times -3. So 1 times -3 is -3. And I put that -3 under my second coefficient, which is the 2. So then I combine 2 and -3. 2 and -3 gives me -1. Then I take that -1, I multiply that -1 times my solution, or what I'm dividing by. I'm dividing by x plus 3, and the solution to that is -3. So I multiply -1 times -3. When I do that, I end up with +3. I combine -5 and +3. when I combine those, I get negative 2. And you guessed it, the next thing I'm going to do is I'm going to take negative 2 and I am going to multiply that times negative 3. Negative 2 times negative 3 gives me positive 6. And negative 6 and positive 6 gives me 0. So let's talk a little bit about what all of these different numbers mean. The answer that I've gotten with synthetic division is 1, negative 1, negative 2, and 0. So now it's super important that we interpret what that means. So this right here, our very, very last answer on the right, that is always going to be our remainder. And as we discussed a little bit in our discussion, our remainder being 0, that means that this is a solution and this is a factor. That's what that means. So our goal when we're doing synthetic division to factor is that we end up with a 0. If we don't end up with a 0 here, that means that whatever we're dividing by is not a factor, and the solution associated with that factor is not a solution. And so then we kind of have to go back and do it again to try to find the solution. This right here is our constant, okay? That does not have a variable with it. There is not an x squared or an x to the first associated with it. You could think of x to the 0 being associated with it. Most students just think of it as the constant being associated with it. This right here is our linear term. Okay, so an x goes with this, and this is our cubed term. I'm sorry, not cubed, squared term. This is our square terms right here. So this is going to be x squared. So my answer, my final answer to this is x squared minus x minus 2. And from doing long division, we know that that's our answer right here. X squared minus x minus 2. So x plus 3 is a factor. X squared minus x minus 2 is our next step in the process. Now, depending on what you're asked to do, you may be asked to find all the factors. And if that's the case, then you would just continue factoring from this quadratic. Now, different things could happen here. You might be in a situation where your trinomial can't be factored, and you might have to use the quadratic formula, or you might have to use completing the square. But just be aware that depending on what the directions ask you to do, you can continue factoring to get the rest of your solutions. But this also might be your answer if you're just asked to use synthetic division. Now, it also works when we have larger or polynomials to a higher degree. So this polynomial right here, this is raised to the 4th power. And if you notice, we have 1, 2, 3, 4, 5 terms there. We have 5 different terms. And we cannot use factoring by grouping when we have 5 terms. We only can factor when I have 4 terms. I can factor by grouping, or I can factor a trinomial using the sum and product method. I could potentially look for a greatest common factor, but after greatest common factor, once we have 5 terms, synthetic division is our only choice. So the important part with synthetic division is you take your factor, x minus 2, and you identify your solution associated with that factor. So my solution associated with x minus 2 is 2. So I am going to put that in my box right here, 2. Then I look at each one of my coefficients. So I have a 1, negative 11, negative 5, and positive 30. Those are the numbers that I'm going to use for synthetic division. So I have 1, negative 11, negative 5, positive 30. Okay? And then I bring down that first term. Okay? And then so I bring down my 1. That's what I just did right here, is I brought the 1 straight down. Whatever that first term is, you bring it straight down. Now I am going to multiply this one by 2. Okay? Because 2 is our solution. So 1 times 2 is 2. 1 and 2 added together is 3. I take the 3 and I multiply it times 2. 3 times 2 is 6. So I put 6 right here. Now I have a negative 11 and a positive 6. So that is going to give me negative 5. Okay? Again, I multiply by 2. Negative 5 times positive 2 gives me negative 10. Negative 5 plus negative 10 gives me negative 15. I take my negative 15 and I multiply by 2. Negative 15 times positive 2 gives me negative 30. 30 and negative 30 is 0. So what this tells me that x minus 2 is a factor of my original polynomial, and 2 is a solution. So if I were to graph this, a 2 would show up as where my graph touches or crosses the x-axis. So now, if you remember, my 0 is always going to be my remainder. Always, always, always. That's my remainder. This is my constant. Okay, this is my linear term. This is my squared term, or my quadratic. This is my cubed term, or my cubic. So my answer here is x squared plus 3x minus, let's do that again. I started with squared, but I need to start with cubed. I have x cubed plus 3x squared minus 5x minus 15. Okay? And we can actually keep going and factoring that. Okay? So if I wanted to continue factoring that, if the directions asked me to find all the solutions to this, then I can factor this one by grouping pretty nicely. So I have x squared. That factors out, and I'm left with x plus 3. Then here I take a negative 5 out, and I am also left with x plus 3. So I'm going to erase some so we can keep moving with this. So I am going to erase all of my stuff here. So we are left with x minus 2 because that was the original given. Then from down here, I have x squared minus 5, and then I have x plus 3. Okay, now x minus 2 and x plus 3 are linear factors. So I am done with those, x minus 2 and x plus 3. You might be tempted to be done with this, but we actually can keep going a little bit with our x squared minus 5. I am going to set x squared minus 5 equal to 0. And when I do that, I get x squared equals 5. And that means that x is equal to plus or minus the square root of 5. So if I want to put this in linear factors, my linear factor is x plus square root of 5 and x minus square root of 5. Okay, so my solutions to all of this are 2, negative 3, square root of 5, and negative square root of 5. And one of the things that we talked about is our irrational solutions have to travel in pairs. Now, 2 and negative 3 are rational. They are completely and totally independent. So we don't have to worry about 2 and negative 3's opposite or conjugates. We only worry about conjugates if we have a complex or an irrational solution. So our square root of 5 and our square root of negative 5 travel together because they are irrational. And if you were to work backwards, you would see that I get this x squared minus 5 is one of my factors when I've got square root of 5 and negative square root of 5. Okay, so this is how we do synthetic division. This is also why we do synthetic division. So hopefully that will help some as you are working through this week's module. Let me know if you have any questions.